Hey Shai Almog, welcome back.
Thank you. Great to be here again.
Yeah, and your second name is of course the debug agent,
Yeah, alias.
alias.
Yeah.
This time
I just
it is
thought
going.
about it this week that I made a mistake because, I told you about how I worked in the office and it was burning and I left out, and I should have called myself Burning Building Coder or something like that. But,
Yeah,
missed opportunity.
like the burning monk. There was one from the character, and you will be the burning
Yeah.
coder.
I missed on that. After the fact, you pick up all these great names, but already did all the SEO work for debug agents, so missed opportunity.
Yeah, but debug agent, I like it. So, and it is a nice page again, and which points to your book and your causes. And I think I ordered your book already, and if I find some time vacations, I will also watch your causes. So this is my plan.
Appreciate it.
And the listeners also should do this. This is the homework assignment for the listeners of the podcast. Very good. Today, I plan to have, the most controversial episode in the history of Airhacks FM. And what it is I would like to find out why Codename One is smaller than JavaFX. So this have to be, the understanding from technical perspective. And what I'm also interested in is first how Codename One works behind the scenes. And then if we find time, which I hope, but I don't think it is possible with us, is to explain your debug, agent strategies and tactics. But let's start with the Codename One. And by the way, to the listeners, what we have a nice place called the Airhacks Discord server. So if you like, join. You can also ping Shai and ask about his causes or whatever. So this just just fun. Okay, Shai. So now maybe I don't know how to start, but what I did, I took a look at Codename One again, and it looks nice, professional, and is fairly popular. So even on GitHub, you have 1.4K stars. What for a Java and 355 forks, and for Java software is actually pretty good. And it looks like you are the contributor number one, and you are a little bit lazy in 2022. So you are far more active in 2016 to 2019. But there is, Shana, which is active right now. And Hen is very, very, very lazy. So critics to Hen, but he has to code more. So basically, you and Shana do the work right now. And you have 3,000 commits to Codename One. So let's cover this because I think it can be still interesting to lots of projects. I mean, how to start, right? So Codename One for me. So
let's start with a few things. First of all, you said that JavaFX is more popular, but that very much depends on how you measure popularity. If you talk about mobile apps created, then Codename One is ahead by several orders of magnitude. I mean, we have lots of actual apps in production from large corporations, lots of businesses depend on us, and real-world projects, not just, toys or demos or things like that. I'm not familiar with anything that actually went into production other than games and that app for DevOps. There's the demo that shows NASA running with JavaFX, but that's on the desktop. They showed it as a demo on tablets, but I don't think that's something that they actually used. And the thing is that when you try to take things that were built for the world of desktop and shrink them into mobile, you quickly run into unexpected problems. And one of the first problems, at least until recently, was that these devices are still much weaker than desktops. They have far less memory and you need to use it a lot more to do lots of stuff on a much larger screen in terms of density. The number of pixels that you need to drive, the way that you need to code to it in the GPU and everything. It's very difficult. And doing that with JavaFX is just really hard. It was designed as a Flash replacement. It was, and there's a reason that Flash isn't running on devices, and it's a technical one. It's not just a fashion one. It's just really hard to adapt to all of these devices. So in that regard, I think we're ahead. Why we don't have 50,000 stars or something like that is mostly me. I think I made pretty much every possible mistake I could with Codename One. Initially, when we launched, we didn't take funding, which was also, again, my incompetence personally. And because of that, we needed to make money. We needed to create something that both has traction and makes revenue. And our starting point was open source, and our product was always open source. But we also didn't really help people who wanted to just use the open source for free. And this really hurt our traction early on and our perception as an open source project. Every time we tried to promote the project, people would go, oh, this is a proprietary commercial cloud solution. And even though we had an open source option, we sort of got quickly sort of blacklisted in lots of places. Like on our Java, if you even mention Codename One, you sort of get pushed out and downvoted. So we're a bit of a project non grata, shall I put it. Also, my stance is against JavaFX because I do think it's a problematic status of a project that was overdeveloped, as I mentioned earlier, over-engineered, mostly because of management mistakes, not because of the engineers. I have the utmost respect to...
So first, popularity, this was a wrong maybe term. So what I wanted to say is better known, right? Because if I mention Java, familiarity, because in a project, I ask someone, "Now, do you know JavaFX?" Yes. Codename One, maybe not. So so popularity was not exact.
I can give you a personal anecdote here. When a few
last
years
one,
back,
because right now I'm now on the JFX repository, OpenJDK. And take a look, it's not a difference. So 2K stars, I would say not a huge difference to 1.4. And if I take a look at the contributor list, so the Kevin Rushforth, he is the main, but in 2022 and 2021, his contributions very similar to yours. And there is another contributor, Arapta. This is his Ambarish Rapta. And he contributes right now, but I would say if you compare, there's also for the listeners, the contribution of Codename One right now with JFX, which is the open source variant of JavaFX, is not that different, interestingly. So still, and we actually, this Codename One just happened. I actually wanted to talk with you with debug agent, so it's interesting that it actually is still a thing. So I would say familiarity, or the term is better known than Codename One. This is what I wanted to express, not popularity and like installation base. Yeah,
that's a huge problem. Back in the day, I think 2015 or so, maybe sooner, maybe 2014. I don't remember. It was still there were still Java ones going around. We had a big customer and we had lots of revenue, and we decided how will we spend that revenue. So we got a booth at Java One. We used to go every year, but just to talk. And this time we got a booth, and I actually talked with 800 people, visitors. And of these 800 visitors, four people knew Codename One beforehand, before I spoke to them. And these are people that come to conferences, to a conference where I have sessions every year. And they still weren't familiar. 796 of them weren't familiar. And I know it's 796 because these are people that I scanned the badges of, I counted. So it's a problem. And a lot of that is preaching to the choir. I tried to promote Codename One, and when I did that together with my day job of actually coding, of running the company, of doing everything else. And obviously, when you do something halfway, it gets done halfway. We didn't have any marketing. We didn't have any of that. On the other hand, JavaFX had the value of being a product of Sun and Oracle. And just by being a product of a company like that, you get tremendous traction out of the gate. You can be on the keynote stage every year at Java One and get promotions through there. All the members of the team become Java champions, where I'm probably banned for life from that organization. And it becomes sort of a problem that feeds
Is it
itself.
true? I cannot imagine that this is true. Shai?
It's pretty much so.
Why
Yeah.
that?
Because I said a few bad things about a particular... I said some things that are kind of negative. I won't repeat them. And
Okay.
I won't delete things that
But
I
against
said
against
in the
JavaFX
past.
or against JavaFX, right?
No, against someone
Against people is more
partially.
problematic. Okay.
Yeah. I get that. I get that it's problematic. The problem is that it's kind of true. So I have a problem with deleting that and apologizing for something that I think is true.
Okay.
And I get that. I get why I'm kind of out of it, but I won't erase history, and I can't apologize to that particular person because I think it's true. And I think he did some serious damage to Java. So, but he's a Java champion, so he got there first, and I'll probably never be one thanks to that. So it's okay. Anyway, but that's the thing. They get a very large platform as a result of that. And for us, every aspect of progress is kind of an uphill battle. And historically, we had to make revenue from Codename One to a larger extent. So we overly focused on the revenue producing aspects like the build service and things like that, and using the open source was a hassle. We had documentation on how to do that, but we sort of said, okay, if you want to do that, you're on your own. And we switched that a few years back, but it didn't change anything. People didn't really change their perception of Codename One being more open thanks to that change. I think part of that might have been my fatigue in marketing, because I'm not a marketer. I did developer relations at Lightrun and developer advocacy, but that's not really marketing. That's mostly informing. And I can't do those things. I'm not really a good marketer, and even in the terms of advocacy, I don't push as well as I should, and I sort of fall into my familiar channels. So people outside of these channels don't get the same message to that same extent. I didn't go to new conferences as much. I didn't publish in new venues as much as I should, and the word didn't get out enough.
But we are talking about marketing, which is for me a little bit less interesting because the technical stuff is more appealing. But my feedback is, and it's also changed over the years, as Oracle removed JavaFX from the JDK or OpenJDK distribution. So my perception was it's over. So because now regardless how skilled Johan Voss is with this company Gluon, it is really hard for a small company to keep up with the entire platform engineering and the different graphic cards and CPUs or whatever. It's really hard. And I actually underestimated Johan's passion for that because he was really into it, and similar person somehow to you because he also ported the Linux and was very passionate about Java. So I know Johan very well, and he's really so passion is number one, and my perception is marketing is number two, whatever. Which is why some Java projects work differently to the outside world, because if you pick a business project for them, revenue and marketing is number one and the technology is number two. And I would say many Java developers are very passionate about Java still, where they cannot be measured by usual business measurements because it is outside of the reasonable things, right? So let's say I like really Sun without knowing why. for instance, right? So this is something like this is not repeatable. So, and maybe in your case was the same. We just like, whatever Sun did because we like Sun and follow Sun. And I don't know whether there will be another company with the same, how to call it?
Cachet.
Vibe. Cachet, yeah. And that's the difference. And the Codename One for me was even worse because it was never Oracle or Sun, right? And I only knew Hen a little bit, and it looked good. But I would say, okay, if they are not successful in business, they will drop the entire project and everything is over. So this is what was. But now it changed. First, Johan proved that he actually over a longer amount of time is able to do this, and if they prove it, means other companies could also achieve that. And now I know your background as well, with the Lewitt and all the stuff. And it is actually doable if you are passionate. And what also changed is, how is called the thing from Google, which is very similar? I always forget the name.
Flutter.
Flutter, exactly. And for me, I would use Codename One or I would use Gluon before I play with Flutter. This is because the risks are the same. So that Codename One disappears or Flutter disappears, I would say Google is not very well known, for sticking to projects. And at least Java developers, I know they are crazy. So maybe, we can rely more on Codename on Gluon. So what I did, so Gluon proved me, and you as well, but I didn't, took a look over a longer period of time, Codename One, proved that actually small companies can provide support over a longer period of time, 5 years or whatever, and it worked well. And now even that far that Oracle they try to reintegrate JavaFX somehow to think. And maybe as a good idea, you can ask Oracle. I don't know about politics, but maybe I could ping Azul Systems or whatever, or other companies and say, look, we have also a nice solution, and maybe something happens there. Who knows, right? Because again, if Flutter is successful, Codename One can be also successful as well. So for me, it is actually for Java developers. I would say the market is not JavaFX. The market would be Flutter for Java developers. This would be my market.
I 100% agree.
Yeah.
It's that was my hope when Flutter came out, that it would improve the market, and essentially a rising tide raises all boats, and sort of prove the need for something, because our architecture is very similar to the one of Flutter. But the result was that Flutter sort of drowned out all other discussion and sort of took over everything. Also, its success was mostly in China driven, and that's a very monolithic market. And they all go as a single block, and it was harder for us to penetrate them without resources in Chinese language and things like that. So it was very difficult for us to capitalize on any success that they had. We did talk with Azul and other companies like that in the past. Oracle isn't really an option because Oracle is JavaFX. And they don't, even if they left it, the people who are still interested in mobile and things like that would have to sort of align with what was officially the product that they issued. They won't go with something like Codename One, especially not because we can't be 100% compliant with Java and current Java to be small enough. That's part of the benefit of Codename One, that we're very small. And part of that is that we're not 100% compliant in terms of newer features of Java, in terms of the module system, things like that. We just can't reasonably do that because we go even smaller than things that they sort of invented more recently. Also, the things on iOS, we changed minor things, but I doubt we'll pass a TCK. Mostly for performance. So things like our string in the iOS version literally maps directly to the iOS native string, the NS string. And that gives us a lot of performance advantage when sending stuff to the UI and things like that. But it's obviously, there are nuances. So Oracle isn't an option. For Azul and companies like that, there's not much of an interest because they provide JVMs for enterprise and things like that. So
but, Oracle is huge, right? What could be an option, Oracle Labs with GraalVM, for instance. This guy's
Yeah,
could be different.
but it's a homegrown solution. The idea, it's kind of it's an upsell to Oracle, and it's a problem. It doesn't fit with the current approach in Oracle, where things go through the Java community process, and it's sort of, there's a problematic fit there, and there's a problematic fit through the industry, because even companies that do mobile to some degree, it's most of these companies are server companies, and most of the audience of Java developers are server developers now. So you end up with either server developers or Android developers. Now, the Android developers work with the Android tools and the stack. So for them, one of the things we tried to do initially was offer a solution that lets you essentially take Android applications, import them into Codename One, and then compile them to everything. And we're interested if something like that would help us gain some traction. But this got very little interest from Android developers. And the reason is most Android developers are either indie developers that are building something on their own, and then they'll just do a native because they're hobbyists usually, or they work in a corporation and then they've got their very specific responsibility of building the Android native application, in which point they just hire a different company or different developer to build the iOS version. So they don't have the motivation to use a cross-platform tool. And similar solutions, by the way, for porting Android applications as is to iOS have all failed, as far as I know. Technically, it's theoretically partially possible, but realistically, you get a subpar product if you do that, if you take that approach. And mostly, the motivations are problematic. The motivation of Flutter is you start with the desire to build a cross-platform application, and that's a more sensible motivation. So the question is, we have an audience of Java developers, but most of them are already in the server side. And they don't get the task of building the mobile application usually. So you're kind of stuck with relatively few people who have the ability to be a decision maker on their own, who are interested in building it with Java and are interested in doing it in building the mobile app as part of the single team. And there's a market there. I'm sure it's as big as Flutter's, but it's a much harder sell when you're a smaller company.
Yes,
and that's
it won't be never as big as Flutter, but I think there are lots of projects where, like enterprise projects, where people don't care. They just would like to write, Java code quickly and ship it to many platforms.
The problem is it's a marketing challenge. It's not necessarily a technical challenge alone. And as a couple of hackers, we're a group of hackers, all of us. None of us are really all that much into marketing, myself included. And it's hard to cross that specific chasm to become a larger presence in this field. And I don't really know how to do that. Not then.
Because what also changed is, the longevity of the apps was a big thing. The Swing apps that they run for 15 years. And the expectation was for JavaFX. I would say now the expectations is different. So if you create a mobile app, no one, believes that it will run for 10 years. I mean, this is like, 5 generations of devices. So you will have to adapt. So I would say the dependence on the platform like Codename One is not that, problematic. Because if you're depending on Flutter, then there is no TCK, there is no standard, there is nothing. So I would say with Codename One, at least, we have Java as a standard, right? So I would say this is different than 10 years ago. Because 10 years ago, it was really, I was in projects where companies asked me, we have a huge Swing applications, how to port them somewhere. And they still believed one-to-one port. They wanted to have one-to-one port, to web, every, view has to be one-to-one ported somewhere else. And I said, okay, this will never fly. Who has, in a web app, 500 tabs? It doesn't work, right? And And this changed right now. So I would say there are lots of situational apps which do one thing very well. And for that, it is not a big deal to be depending on, let's say, proprietary, not TCK compliant product. And maybe the problem was that if you try, to market Codename One as a standard, which it is not, many people become angry, myself as well, because, a microprofile in Java E for me is a standard, not a standard, not a standard. But if you say, okay, we are pragmatic, so we do whatever is necessary to make it run fast on all platforms, and at least we use Java, that changes completely the conversation, and no one will criticize you that you are not a standard, right? Because you are just an pragmatic toolkit to build mobile apps. I'm just curious because really this Codename One was no more on my radar, and now it's still alive. So I become curious what I can do in my projects maybe, because why not? I mean, again, we have lots of projects. I tell my clients, Codename One is a small company, but it works well right now. If 5 years is over, we don't care, right? If say yes, then go for it, right? I mean, this is an honest discussion, and but you have no guarantees in Flutter that it will work, and you have even less guarantees in Angular that actually it will work the same way. So this is actually complete different world.
You don't, if you program to mobile, you have no guarantees in native, because Apple and Google change things like every other month. And every few months,
I don't know what your opinion is about Android. So my perception is Google doesn't like Java and Kotlin a lot, and they would really like to have their own native stuff, right? So I think they would love to have their own operating system. So this is my guess.
I doubt that. That's
okay.
That just won't happen. There's
the fuchsia, the fuchsia. I think it's called.
Fuchsia.
Fuchsia, okay.
That won't happen. And the reason it won't happen is because Google doesn't control Android. It's the reason Android is powerful, and they do have they made it closed source thanks to Google Play Services. So Android is no longer open source. But Android is popular thanks to operators and manufacturers. There's sort of a delicate balance that Google was able to achieve because they were in the right place in the right time where everyone was afraid of Apple. And they sort of got this coalition of the willing, so to speak, between all the manufacturers, all the operators to build this sort of thing. And now that they dominate this field, they can't really replace it without full compatibility and without at least a significant batch of collaborators who are willing to move. And they will need to also move the apps because they need the customers to also move. And this is actually really, really difficult because building an entire ecosystem from scratch is huge. And I don't see them able to do that anytime in any sort of reasonable amount of future. Because they would need to rewrite all the apps. They would need to adapt all the devices, all of the stacks within the devices. There's so much stuff to do there. And it's just not something that everyone is willing to collaborate on just because Google doesn't like being with Java or with Kotlin, both of which are essentially the same side of the coin, because even if you port everything to Kotlin, it's still a type of Kotlin that depends on a VM under it. So they can't really throw away the JVM. They might be able to change it a bit, although it's not technically a JVM there. It's an AOT sort of system that's based on Art, which is runtime that's kind of JVM-like, but
Dalvik, right? It's still Dalvik?
Yeah, it's still that. It's just right now it's called Art, which is Android runtime, and it essentially uses more AOT when installing. So you get better startup time performance, slower memory overhead, and stuff like that. Although it's still pretty fat relatively to what it could do and to CDC and stuff like that we had decades ago. So frustrating.
Okay, now if we consider JavaFX technical stack and Codename One technical stack, if we just consider JavaFX so roughly, what happens from the not maybe CPU, whatever's reasonable, from the JVM perspective? Maybe start with the JVM up the stack. So what I understood is JavaFX is completely rewrite, so there is no more swing, so they have their own graphics pipeline. This is what they are doing, and they are more flexible. And can you just briefly describe what JavaFX is doing? And then I'm interested in the differences to Codename One.
So JavaFX has a few nice things there. It was built for historically, Swing and AWT used immediate mode graphics, which meant essentially every time you draw the frame, and in AWT it doesn't matter, in Swing it's still a lightweight interface where it draws everything. And every time it draws the UI, it essentially gets a graphics object and you just draw all the elements. So if you have a button you see it on the screen, it literally draws the square, it draws the text, it draws everything. With JavaFX, you usually work with a scene graph mode, which means you essentially declare that there's a square over there. You build a sort of a structure similar to a DOM structure, and then the rendering pipeline renders it when convenient. And then they built a widget stuff, the button and everything on top of that scene graph mode. Now, this is actually, if we look at mobile interfaces, by the way, Android took the approach more similar to Swing, where every UI element uses immediate mode, and iOS took initially the immediate mode and then switched to using something closer to scene graph.
Swift UI. What do you mean? You mean the Swift?
No,
Swift
UI? even before Swift
okay.
UI, they took that approach. Canvas something UI Canvas, if I remember correctly. I'm hazy on that a bit. So the thing is that these approaches, the advantage of immediate mode is that you get more control, but the disadvantage is that it's really hard to program efficiently for the GPU and still be generic. So the GPU accepts sort of commands, and it's really good at blending and doing all of those complex things where you need to sort of have partial transparency and things like that and a blur effect. It's really good at that because it can do all of that composing in hardware. And imagine a painter's algorithm where you need to draw things from the back all the way up to create those effects like transparency and blur. So you need to go all the way back and draw all the pieces. And the GPU can do that for you sort of for free with a single command. You just add a shader and it does all of those effects for you when you want to render things. So with the scene graph structure, you can sort of build all of these shaders into the GPU and build all of that stack all the way up. The problem is when you build these things and they don't work as you expect, suddenly it becomes really, really impossible to debug it or to understand what's going on because it's an internal implementation detail. And you as an end user don't have any tools to dig into that. You sort of need to go into a debugger built for the implementer of the scene graph and understand what happened in terms of the GPU. And things can perform really badly. Also, when you want to express things that are complex there, for instance, say you have a chart that has 1 million points on it, which isn't something out of the ordinary. Will you add 1 million points into a scene graph so someone can zoom in? You can't do that. So it gets very complex to build some things that are supposedly trivial to implement. And in immediate mode, it's more intuitive sometimes for developers. So we use immediate mode, which, as I said, it has advantages and disadvantages. And we made it work reasonably well with the GPU. I can't say that it's perfect, but it's good. And JavaFX has scene graph mode. And despite that, it usually doesn't really utilize the GPU well enough because that's just really, 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 really hard to code. And I've looked at some of the code for not even the scene graph, for the immediate mode stuff and the JDK itself that we did back in the day. And it's insane. The stuff that they do there for support of shaders and it's really hard code to write at scale because it's not just coding. You essentially generate code dynamically and adapt it so it will mix with the Java code. And you need to constantly transfer textures in a smart way because textures have limits in terms of what you have. It's very low level stuff. And it's something that you need a huge team on to build. And
So okay,
other than that,
let
Java,
me rephrase that. So what I understood is so the JavaFX is based on a scene graph. So there's everything starts with like a canvas, and there's a nodes, and the nodes are similar to concept is similar to DOM, like in HTML, and the DOM the nodes are somehow painted. But what I understood is immediate mode in Swing was one-to-one mapping between the UI and the painting. So every button and text field were painted by themselves. And the JavaFX, you are working with a tree. No?
So no. So there's two layers. There's the graphics layer, which is the layer where you draw the shapes and text and things like that.
Like Java 2D.
In Swing, it's immediate mode. Exactly. So Java 2D is an immediate mode API. In Java 2D, you get a graphics object, you just draw a square, and the next time you render, you need to draw the square over again and over again and over again.
Exactly.
In scene graph mode, you place a square on the screen in a specific coordinate, and it will be drawn on forever. You never need to draw it again. You just place it there, and it stays there. And
that is similar to
that's
web.
sort of a DOM-like.
Then in web is similar. This is other way around. So the JavaFX would be more like a canvas in web, where you're drawing your stuff. And what Swing did with Java 2D was more like a DOM, where every DOM node was somehow transferred to the browser.
No, so that's the component. That's the component level. On the component level, they both have a sort of scene graph structure where you build the component hierarchy. So both of them have that same sort of concept. But for the graphics layer, which is a separate layer from the component widget layer, there the scene graph is what matters, and there you have. In JavaFX, it's a scene graph where you build a sort of structure in memory, and that structure sort of gets drawn for you. You don't have control over the drawing process. And in Swing, you need to draw the frame every time. So
because you don't know, there is no relation between the nodes, right? This is the problem with Swing. You have the Java 2D is painted everything, and you necessarily don't know if an effect like shadow, whatever affects a button. What else is affected?
No, you don't
right?
know. You don't have that structure.
Yeah, but in JavaFX you have, because the relation between nodes, you know which nodes affects which nodes, and you can draw whatever you like in the node. But this is why it is similar to CSS a little bit, because they also have borders and whatever.
And SVG is also a scene graph. So in a sense, it's very similar to that.
But how they got the idea in JavaFX? Was JavaFX based on something different, or was it a fresh idea?
It was based on F3. So over there,
now
the idea of scene graph is from there.
How Chris got the idea for the scene graph?
So that's from Flash, and it's not a new idea because it predated Flash as well. The idea of scene graph versus immediate mode is ancient in terms of computer graphics.
Okay.
And generally, because OpenGL is an immediate mode API, a lot of APIs chose to go with immediate mode because the hardware worked that way, and still does to some degree. But the advantage of scene graph is that when the hardware is really, really hard to manipulate, especially when things get more complex with compute and things like that you can leverage potentially on the GPU. And the advantage of placing as much as possible on the GPU is tremendous. You can do a lot of the rendering heavy lifting without essentially activating the CPU at all. And the problem is you need to be very savvy to program in that particular way. And doing that on a device is really hard because there's changes and nuances and limitations. Because, if you take a texture, an image that you see on the screen, it's really a texture on the GPU. And the textures on the GPU have very specific requirements in terms of size and everything that you cannot upload there. So and uploading a texture from the regular memory to the GPU memory is something that's expensive. So you constantly need to be very calculating in terms of what you'll place on the GPU, what you remove from the GPU, because you don't want to overextend yourself and essentially deplete that memory. And you need to pay the right amount when you're trying to optimize for that device. So these things are really hard to code normally, and in a scene graph situation, it's even more difficult because it needs to make these decisions for you, and they vary
because
based on the
interference
device.
between nodes is the problem, right?
The problem is that, say you have one node that has an image, and then another one, an image below it, and another one below it.
Exactly.
And you start uploading textures for all of them into the GPU, and suddenly you run out of texture space, or one of them has a texture of a bad size that doesn't match. So you need to take up too much space to sort of fill, and then crop out the empty space and create a sort of effect. There's lots of decisions you need to make on the fly to sort of fit into the way that the hardware is built, and doing that through
and this is why you told me
really difficult.
Told us with the code generation, because you have a stack of nodes and you have some effects between the nodes, so if you walk the stack you could generate the code for the GPU. This is why you said you're generating the code, right?
No. The code generation is part of the VM itself, not in terms of the UI.
Okay,
the UI
because I thought this is like, you are walking the path and then you think, here, this is the blend mode and this is, and you can, no, okay.
Now, there's a GPU project for Java. The name eludes me right now. It's a really cool project, but that's for desktop. That takes JVM bytecode and essentially uploads it to the GPU. It's a really, really cool project. The name will probably come to me after the show notes.
Yeah. But whatever you said, it is still no reason that why JavaFX is larger than Codename One. I mean, whatever you said makes sense.
That's not larger. That's why it's different. It's larger because they have more classes. It's just for a hello world, they require a lot of classes. And
why that?
That's because it was designed for desktop, and the limitations, they wanted to design something, an API that was beautiful. And Swing is also pretty big, and they took it beyond Swing in terms of the sensibility when they built it was to write as many classes for everything and do everything very generically. In fact, one of the problems they had back then, and one of my good friends at Sun was the guy that was responsible for writing JavaFX embedded. And one of the big difficulties they had was the fact that JavaFX used lots of generic lists with autoboxing and things like that all over. And that's really, really expensive in terms of performance. And on mobile, we're talking 20 times slower than just using a primitive array. And they did that all over the code because they wanted to be as generic as possible. And on the desktop CPU, it might have not been a difference, although I think it was, because even today you see the difference in terms of performance to a smaller degree. But back then it was very noticeable, and it was a real problem. So they created lots of classes for everything, encapsulated everything to a very large degree.
So the problem is not the rendering pipeline. The problem is the widgets and how the framework is designed, right?
The amount of classes, the indirection, the levels of abstraction, and also the complexity of the graphics pipeline. That's not the size, that's just the performance.
Okay.
It's it requires a much more elaborate graphics pipeline than we do. Our implementation is complex, but it's relatively simple and very conservative in terms of the APIs that we need from the underlying platform. I mean, it worked on a 2 megabyte Nokia, so it works efficiently even on today's phones because it was designed to fit at a really small footprint and be efficient visually on the screen in a very small constrained environment.
So the marketing message for Codename One would be like, ugly but small and fast.
I don't think it's necessarily ugly. I think we did ugly stuff because we didn't have a designer on staff at all. But
no, I mean ugly from the class perspective, not from UI.
Well,
because if JavaFX wanted to be generic, and they wanted to have beautiful APIs, and you say, okay, we are more direct, maybe
I
it
think
is not
small and simple is
small and simple. Okay,
probably more
less abstraction, more direct.
More my choice of words. We essentially copied the design the design sensibility in terms of classes from Swing. We just took out all the crap we didn't like it in Swing, like the J hierarchy stuff.
And not Luit?
Which
was not based on Luit more?
Luit copied the ideas of Swing.
Okay. But Codename One is more based on Luit, right?
Yeah, it's literally the Luit code refactored and further cleaned up a bit. But yeah, it's still the same basic code. You can still see all of that.
So now, what is the pipeline of Codename One? If we now got the idea about JavaFX. So if you consider Codename One from the VM perspective up to I don't know, the Hello World button on the screen. So what happens there?
In terms of rendering or in terms of the VM and everything?
Just a comparison. So we covered the JavaFX with the Canvas and Scene Graph. And now what's the difference to Codename One? So I would just like to have a comparison, for the listeners. So the Codename One behaves a little bit different.
So with us, it's closer to actually just drawing. If you run on iOS, it's just an OpenGL or ideally in the future a metal call that just draws the text of a hello world. When we want to draw text, we literally invoke the text drawing function of iOS and draw it onto a rendered bitmap and just blit that directly. So it looks exactly like it would in a native application. We use the same fonts of the system and everything. And this is a large value proposition.
If you have a button?
The button we draw. We draw the button, but text, we use the rendering system of the OS, which saved us from a lot of the complexities of text rendering, because rendering text in a way that is cross-platform is just really, really, really difficult. So we sort of cheated our way out of it by using the native system's rendering of text. And
which is a good idea.
Rendering it.
No?
Yeah.
Because people are very sensible regarding fonts. No? People are very sensible regarding fonts. And if you would draw your own text, I would think it would never fly.
So in JavaFX, they do draw their own text because they don't have a choice. It works in a very lightweight way. So they need to draw everything and they need to have control over everything. And the fact that they can't take these shortcuts because they took the sort of high road of doing everything in a particular way limits them when they want to do things that are more flexible. So for us, all of the interaction between the native widgets and the way that Codename One renders and everything is very much tailored to every specific platform. And we don't have a unified rendering pipeline. So on Android, the way we render is very different from the way we render on iOS. And it's very different from the way we render on the web, because we also support a web target. So every single one of these platforms and Windows and everything else, everyone has a completely different underlying implementation, 100% rewritten. And for each one of them, we take the right type of shortcuts to make it look better. The initial implementation, for instance, on Android used double buffering, which was a common approach to render back in the day. And but that stopped being efficient in Android, I think, circa Android 4 or 5. I don't remember when. It just suddenly became really slow. So we completely rewrote the pipeline, I think, a few times by now. And we adapted it to the way that Android works today with GPUs, so it works better and is more fluent. And each one of those platforms, we did a completely different implementation. Now, the VM is also completely different between the OSs. So on Android, we just use the Android VM. We don't reinvent the wheel in any way. And that's one of the reasons we're very efficient on Android. On iOS, we have the ParPar VM, which we wrote. And it just translates to C and then compiles in xcode. So it's a native application in every measurable way. And sign in xcode and everything. It's literally, you can download an xcode project or just generate an xcode project and just compile and run it directly.
But this is
brilliant. You can even debug it. Yeah, that's one of the things I like. Yeah. You can debug it. You can see the function names map to the method names in Codename One. And you can actually see the name of the method there and set a breakpoint. And if you get a failure, you can see a stack trace. And the stack trace is readable because it maps directly to the stuff in Java. You can run the profiler and see the performance output and everything. It all works natively on the device with the debugger, on-device debugging and everything. And that's really cool. And it's also forward compatible because Apple will continue supporting xcode. Worst case scenario, you might need to fix a thing or two there, but it will work.
But is it the code is understandable in Xcode, or is just read only? Write only.
So I can read it.
Okay.
It looks kind of like a bytecode, so I'm sure you can read it to some degree. It takes getting used to.
Okay.
Obviously, initially, some people get panicked because of the size. But once you start using it, they understand how to work with it, and they understand the boundaries of the methods and things like that. It's not something you would maintain. I wouldn't maintain it as is, but you understand where it goes. And one of the nice things there is that the garbage collector is written into the code. So you literally have mark methods all over the functions, all over the code for every class, and you can see the mark sweep process and place breakpoints on that and see how garbage collector actually works on the device. It's really nice.
What do you do in the web? I'm curious now. So you said you have web target. What happened
in the web? So in the web, we used TVM, which is a great virtual machine for JavaScript. And it lets you generate JavaScript code from bytecode. The author of that also wrote a version of that works with ISIM, as far as I know. But there's really no need for that. The version that generates JavaScript is super fast and really small. So it generates a relatively small application that loads almost immediately. And there we use just Canvas to draw the UI.
So this is what I suspected. So your architecture is very similar to Flutter, actually, right? So what you also mentioned that because you are actually drawing, everything natively in the graphics pipeline. And if I have in JavaFX a button, is it going to be the native button? And your button, also no, it's also drawn.
No, we're very similar to JavaFX as well because both of us derive from Swing in a way.
Okay, but Swing was able to provide a native buttons at one point of time on desktop.
AWT provided a native button.
And Swing
allows you mixing.
Exactly.
What you're talking about is mixing. So Swing didn't have a native button, but it lets you mix in a native widget and still work with Swing, which wasn't possible in the initial version and wasn't possible for years. In more recent versions, it allowed you to mix native and lightweight widgets, and we allow that in Codename One as well.
What I remember distinctly, I had Windows Vista back then, and there was an announcement from Swing team, I don't know which Java it was, that on Windows, they are using native widgets right now. That's what I remember. And they look differently, and it was faster.
Native theming. It was, I think, native theming. They didn't use
some widgets, like buttons, I think this were native Vista buttons, no more drawn. So maybe I was wrong. You are right. So you are the expert on UI level, but this is what I remembered. Okay, so it means everyone draws. You are drawing more directly, and JavaFX because of the scene graph indirectly with more generic thoughts or strategic thoughts, and you are more better. So you are very Flutter for Java developers, right?
Sort of, yeah. It's the architecture of Flutter is also similar, although unlike. So Flutter works a bit more. Flutter needs a native virtual machine. It can't run on top of the JVM. So in order for that virtual machine to run, actually they don't like it when I call it a virtual machine, right? So they claim that it's a runtime, not a virtual machine, which I think potato. The moment you're AOT compiled, same thing. Where's the line where you say virtual machine when you have an AOT compilation? So they have a runtime that's separate from the runtime of the Dalvik system in Android. So if you have a Flutter application and it needs to communicate with the Android Dalvik environment, it needs to sort of go through JNI. Now, they have a sort of a bridge with which is supposed to provide events faster, but without the JNI overhead. But obviously, there's complexities there because it's a single-threaded environment where they need to somehow communicate with the native Java, because on Android, native is Java essentially. And it's a process. It's not necessarily trivial there. On the other hand, they did a lot of optimizations there. So they go directly into the graphics in the native code without going through Java. And that way they're able to provide a reasonable frame rate. And they also branded it really, really well. Instead of going out and saying, oh, we're good enough, they instantly went and tried to claim high performance. And people buy into that, and it isn't wrong. They did a lot of work there in terms of performance.
I like the Dart language as well. I mean, at least with the Dart, it is okay, but I would still prefer Java. But I prefer Dart over, I don't know, other languages, I would say. So the choice was nice. Yeah. So now the questions regarding Codename One. Let's imagine I have nothing on my machine. So I have fresh MacBook. What I have to install to create a text field with a button which sends, a REST request to a Java backend. So let's say I have
nothing.
Okay, but how to start with Codename One?
IntelliJ or VS Code. Just start.codename1.com. You can work with VS Code. Start.codename1.com. Select the IDE that you want and just download a sort of a Codename One initializer like Spring. And you just download a zip project that's in Maven, and you just unzip it and open it in your IDE and start working.
Okay. And in order to ship it to iOS store, to Android store, and have a web target, so what do I will need to do?
So you need to. There's a guide for building the Maven applications. There's targets within the Maven.
Okay. That
target each one of those different targets, so to speak, and some of them work locally. So, for instance, you can generate an xcode project and just compile it if you have a Mac, and that will work for you for iOS and stuff like that. Or you can send a build to our cloud servers, which generate a native application for you, and then you don't need a Mac. Which you get a free quota every month or so.
And the web part.
The web part is in our enterprise plan.
Okay.
That's how we make some money. And that's there. The other targets, the iOS target, the Android target, and the jar target for desktop are all completely free. We also provide free quota for Windows builds, for iOS, for Android, and UWP, which is a Universal Windows Platform, stuff like that. And other targets for desktop, we also include targets for desktop installers for Mac, for iOS, for
Do
Windows,
I need your cloud, or could I build everything by myself?
No, you can build most of the stuff by yourself. The web version isn't open source.
No, there's no problem.
That's not an option.
What
the other targets are all open source.
So I can build it on my machine and ship it.
Yeah.
So what is the added value of your cloud then? Just to have more CPU
You don't need
power?
a Mac.
Okay.
You don't need a Mac for that.
Okay.
You don't need a Windows machine for that.
Okay.
And the fact that
so multi-OS deployment, right? Multi-OS deployment. So I have one machine regardless what it is, and I push to your cloud, and you're creating binary for all targets. Okay, this is like metrics build. Okay. And where your cloud is running? On Azure, AWS?
So parts of it's highly distributed because of the problem. We need physical Macs to do that.
Oh, okay.
And so we have a host for Macs. We have another host for Windows. We use Linode for most of our machines, Linux machines. And it's very hodgepodge sort of thing. Initially, we started with App Engine and sort of burned to the on that thing. But unfortunately, because of the way that cloud vendors sort of grab hold of you and won't let go, we're still stuck with that, still running, because some services still depend on that. It's really, production pains.
I have to say, I like your approach with Codename One. What I did, I also did some project with Flutter, and the initial experience was terrible. I don't know whether you try to install Flutter. It was like, it was like 2 years ago. no kidding, I think 1 hour to set up until everything was downloaded and re-downloaded.
1 hour is good.
Yeah, I say, yeah.
Mobile is difficult.
And this is what I don't understand in general, I'm from, beginnings of Java, and everyone would say, turnaround cycles and installation experience and application servers are terrible. But I use the application servers all the time, Glassfish, Whitefly all the time. And sometimes I install the servers daily because I was lazy. I deleted everything with the caches and reinstalled the server, and it was a matter of 2 minutes. And now we got the new frameworks, which takes 2 hours to install, and no one complains. So we say, okay, this is like the greatest stuff. And if you take a look, it is way worse what we had in Java, 10 years ago, if you think about this. And in our community, everyone complained it's heavyweight and whatever, it takes forever. But even WebSphere, I think I didn't like it at all. But I mean, if you compare it to Flutter, WebSphere was lightweight, right? From the installation perspective. So this is what was interesting, right? Hey, Shai, this was expected. I have to reinvite you back. And just to talk about debug agent now, just about debugging, debug, if you like, debug strategies, your book, because this is actually, and this was supposed, to be one podcast, one episode, and now we have, I think, 4, and I'm not sure whether we will cover the debugging in one. It depends on you. But I'm really glad about Codename One, because now it some transparency and listeners can decide, whether it is, and maybe take off. I mean, for me, it is no reason not to take off if you communicate clearly, okay, we did some shortcuts, it's it's not a standard, but I mean, who cares? Nothing else is standard, right? Then this is a complete different situation to, what we had, the JCP and JSRs and JAPs. This is complete different world, whether you're building, a situational app, build it fast and save time right now, even if it dies in 2 years. So you build it differently. I mean, it's not like, I also don't believe that if you build something with Flutter today, you don't have, to reconfigure and rebuild in 2 years. So Flutter also changes. So there is no stable environment anymore, I would say, in UI at least.
Yeah, I think Flutter's architecture is far more complex because it includes the full stack of the architecture. Mm-hmm. And we kind of rely on Java, on the platforms where it works. Mm-hmm. So we have the sort of crutch that we use to build a lot of stuff, and we can just build on top of that instead of essentially porting the entire VM every time. And we use more of the capabilities of the native platforms, take more shortcuts, and because it was built with a smaller team, it's simpler, more more of a found technology, I'd say, process of building it. And so I'm for the keep it simple approach.
Yeah,
and
for me as well.
And Flutter
I would
is
say,
large.
And for me, it's either, you do something with lots of abstractions for a reason, like standards, or you have all the shortcuts, keep it simple and fast. And if the strategy is clear and clearly communicated, it's just perfect. This is what makes software maintainable. You have to know why you're doing something, right? The verse is, this is what is funny in most enterprise projects. There is no reason, not to be KISS. And they, create 20 layers because one day a table can get, one column, and therefore we need 20 layers and translators, whatever. This is what I never got. But perfect. Thank you a lot, Mr. Debug Agent.
Thank you.
So this is I think the only debug agent or burning coder in the world who can explain 2 Java UI stacks, right? So, and your book is not even about UI; it's more even Kubernetes is covered a little bit, right? So what I saw, this is actually crazy. So I'm really curious about your debug strategies, and thank you a lot. Where people can find you?
Thank you. Debugagent.com and at debugagent on YouTube, Twitter, etc. And Shai Lamorg, obviously, you can Google it. I dominate Google.
Very good. So the dominant Shai on Google. Thank you.
Yeah. Thank you.